this one and try to calculate the design and the maximum creditable earthquake with a risk or risk associated maximum creditable earthquake spectra. I will be showing you the website from which you can download these data values and how to get this data value in your calculations, right? So last time I had given you all the average shear velocity and the type of the rock, etc. Main part is this, that this risk targeted maximum considered earthquake, what we call it as a MCER, this can be obtained from the USGS Seismic Design Geodatabase. I'll show you how to get that. So there you will be getting these 4 parameters: SS, SA1, SMS, and SM1. So as I told you, these are all 5% damp response spectra as you have calculated from your data. 5% damp the response spectra. These are all the same thing. But these are so these are for the B or the rock type. So at the rock, this is the values. At the SS means it is a 0 point. So this is SS, the suffix S is a 0.2 second spectra, and the suffix 1 is always the 1 second spectra. Okay, so the 1 second 5% damp response spectra, and this is the 0.2 second damp response spectra. And the MS is the MS and M1, these are the site corrected. So these are the site corrected MCER. So that means site corrected response spectra. So this is only for the rock site. SS and S1 are for the rock site only, and MS and M1 is the site corrected spectra. So that means the site is already corrected for that one. So if you know these 2 values, you do not need all the 4, you may need only 2. If you have this SS and S1, you can convert it into SMS and SM1 by using the relation SM1 will be equals to FA into S1 and SM, okay, SMS, this will be equals to SV, and this is your FA S1, SS, right? So if you know this SS and S1 value, you can calculate SM1 and SMS values by using a correction factor. This VA and FA, these are the correction factor. I told you last time, these are the correction factor for different spectral acceleration. You can do that. But if you already got SMS and SM1, you do not need that. Okay. So if you know this SMS and SM1, then you can calculate design spectra. This is called DS and D1. This design spectra used for the, this is used for the seismic design things. These are used for the seismic design. So these are basically seismic design spectra. So SDS and SD1, again S means it is a 0.2 second, the 1 means it's a 1 second, right? Okay, so if you get that SMS and SDS, so you got that SDS and SD1 value, then there are 2 possibility. One is the design response spectra I can calculate based on some multi-period design response spectra. So that means these design spectra can be calculated with your multi-period values of this one. Okay, so these are all multi-period values they had given, and you can calculate it based on that. So these period values are all given here. So on these period values, they are calculating the spectra up to 10 seconds, right? So that is the new things which has been given to the design people. So that means this is the multi-period design spectra. But multi-period design spectra are basically computed by the interpolation of the data values from the known 2-point values. So that is what you can calculate. So the spectral acceleration is basically the 2/3 of this 5%. This one, so as I told you there. Now, if it is a 2-period design spectra, the earlier one is a 2-period design spectra, where the design spectra given at a 0.2 second and at 1 second. So if I know these 2 points, I can draw this line. Okay, so that is what the 2-point design spectra. So this is the 0.2 second values. This is the 0.2 second, and this is the 1 second, right? So that is your this number. So this is used to, this function is used to get this line. So this is your straight line from the t value. This is the time period t value. This will be equals to t by t0, and this t0 value can be calculated based on SDS and SD1 ratio. Let me tell you how to calculate this T0. Okay, so T0 is equals to 0.2 SD1 by SDS. So if you know SD1 and SDS value, divide it, multiplied it 0.2, then that will be equals to T0 value, and TS value, sorry, this has to be the TS will be equals to SD1 by SD1, these things, SDS, right? So if you read these two values from your SM1 and SM3 as a 2/3, you can calculate this. So this is your TS value. Okay, so if t equals to 0, so that means this point t equals to 0. If your capital T equals to 0, then this value is entirely 0. So SA, the spectral acceleration SA will be equals to 0.4 SDS. So that we have told you last time. So that means this point is equals to 0.4 SDS, right? So this is 0.4 SDS, and then you draw this line by the intermediate T up to T0. You will be all calculating with this formula, you will reach here. Then you draw your SDS number and you extend this up to the TS value. So TS equals to SD1 by SDS. So that calculation you did, and then that will be equals to your TS number. So you extend it. So that means this will go up to this and then up to this much. And after that, you plot your SD1 value at 1 second. So that means this point is being marked, and then this will be joined by using this relation SA equals to SD1 by T. So that will be gone up to this TL, right? So that is with the TL. Now what is your TL value? TL value, you read the TL value also from the map. So this TL value you will be read from the map. Okay, so this is from the map, from the spectral hazard map. You will be read this value. The TL is called long period transition value. Long period transition. This is your TL. So up to TL, that means from here to here, this will be goes like this, and this formula is this one. So you can calculate this one up to TL, and then the beyond TL, if you need the more data, then that will be equals to SD1 by TL by T squared. So then from here you take this number and then calculate this portion of the graph by this formula. Okay, so that's your 3-step equation to draw a design curve, and based on this design curve, your spectra or your design spectra you can use for computing the time series of any place you want. So now what you have to do is this, that say suppose at a particular place you want to build a building or a structure. So at that point you need to give the latitude and longitude. So that point latitude longitude has to be given, and then you have to give that what kind of structure you have to generate, and also you have to give that what is the soil type. So this is soil type you have to give, what is the structure, means what kind of structure. It is a risk with a number 1, number 2, or number 3, or number 4. I told you last time that these are the 4 let me see. These are the 4 type of structure we had talked about yesterday. So that number 3, number 4, so that you have to tell them. So if you tell that, then so I have told you last time that the building other structure which is human, which has a no risk, that is. So these are the building type structure. So these are the 1, 2, 3, and 4. What kind of structure you have to give? So latitude, longitude, risk associated with that structure, and then number 4 is the VS30 or the average shear velocity or the site class you have to give. And I have given you the site class definition, A, B, C, D, BC, CD, D. So you have to check that you have to give, and then the program or the USGS geodatabase will give you all the values. Let us do that and try to see you the numbers. So this thing is called ASCE Hazard Tool Online, ASC 7 Hazard Tool Online. If you can hit that. So this is the ASCE hazardtool.org. Okay, so this is ASCE Hazard Tool, American Society of Civil Engineers, hazardtool.org. If you use that, then that tool come here, and then this will be the United States map. Of course, there will be no Indian map I can generate here, but let's see, this is the United States map. And then you have to have you can use either the address, if you know the road and site address, you can use that, or you can use the lat and long. If you have that lat and long, you can use that, or you can put it onto the map. So say suppose if I say that, okay, let's do it for the Los Angeles. So if you can come here, put the things, and I said the find on map, and then this will be come here as a where is the Los Angeles goes? Okay, this is close to the Los Angeles. It's fine. I just try to give you an example. So Los Angeles, and let's see the seismic risk associated might be, this will be the category 3. You can hit the category 3 for these things, and then also the site class, you can give a site class. Let's see, this is your stiff soil, let's see. Okay, so that you have to confirm from that.
I've seen some things similar for India, maybe for Odisha side. Like status and things are other name. Like I don't remember from GIS to like the different one.
It would see, but I am not aware of it because could have been, but I am not aware. But it is there, and it could be generated for India too. There is nothing great here, but everything has to be, because these are all GIS type of things, and if the information is available, it can be incorporated. Okay, now there are.
I can give the customary unit. You can use the SI unit. The customary units means it's a FPS type of unit, which in US we all use that unit. And if you use meter per second square and all these things, then it is the SI unit you can click. And there are a lot of loads. This is the wind loads, ice load, rain, tsunami, tornado, flood, snow, all this. But I only need the seismic load, right? So that will be the only thing I need to do. So you put these things, as soon as you put, they know what you need to find it out, and then you said that seismic, so they will ask you the view results. So click the view results. Okay, so click the view results, and then it will be the there are two things. One is the full report. Let's first calculate the full report. Let me see. This is the full report. You can click, and your report is processed. This may take few minutes. Okay, let me see. There will be something will come to my download box. Yes, it has come here. So this is what I clicked, right? So when I clicked it, then they said it is a standard AC 722. The risk category is 3. The soil class is D, and the latitude longitude is given, and also they give the elevations, right? So if you give that place latitude longitude from the GIS database, they can also find it out that. And then this is the value of that site. They are giving it to you. So that is your SMS is this one, SM1 is these things, SS is this much, S1 is these things, and SDS and SD1 all are given. So this is all according to that formula. They have given all this. Now, in a seismic design category is D, because that site class is D. Okay, so they have to give you the D class soil, and these are the two spectrum. One is the multi-period MCR spectrum, and this is the 2-period spectrum. So the 2-period spectrum means it is drawn with a 2 point, one is 0.2 second and one is at 1 second. So based on that, this spectra was been drawn, and so this is from the multi-period spectral values, and this is the multi-period design spectra, right? So that means SDS and SD1. So this is your SDS and SD1 value, and this is your multi-period design spectra, and this is your 2-period design spectra. So this is the 2-period side. One is MCR and the design, and this is your 2-period side, MCR and MCR design spectra. Is it clear to everybody? So this spectra you can get. Now if you want the details, So they will give you the details value, right? So if you click the details, they will give the details value for the same result, SS, SDS, and the VS30. They put the VS30 because you have given the soil type. So then SD1, S1, all this number, and this is your multi-period design spectra. You can see the graph, you can get the table, you can have all the table, tabular value for all that particular period, all the up to 10 second. You can see all the values they have given, and if you wish to put it in a database, you can get it as a CSV. Okay, and this can also be multi-period MCR spectra. So this is your design spectra, this is your multi-period MCR spectra, and this is your 2-period design spectra and 2-period MCR spectra. So that you can, and you can see it here, the MCR spectra is 1.8, but the design spectra is 1.2 because it's a 2/3 of that. Okay, so that is where, so that means this is at a 2/3. So if you multiply this one with a 2/3, then this will be this one, right? So that's the pure mathematics. Okay. We also can have the vertical response spectra. These are all horizontal response spectra. Okay, so it is for the horizontal movement. So we should not be use it for the vertical or the bridge type of things. If you have a bridge, then we need to use mostly the vertical design spectra will be useful. But this vertical design spectra till now has not been formulated in the form of a this type of things. It is still under processing. Okay. But we have a horizontal spectra that is mostly used for the building structures and all these things. Is it clear for everybody? So how to generate these two spectra from the web, because these things are all available in the web, because they had not given till now all the mathematics here. I have the mathematics, I can give you the MATLAB code to calculate all these things, but whenever this MATLAB code will be calculated, the MATLAB code will also call this program and this web program, and they will be calculated based on that, because this is a huge one with all latitude, longitude. It will not be very easy to do. So unless and until you do the things calculation in a web, it will not be possible to compute. So that is what we have got it from here, right? Okay, so you got the design spectra. That's the bottom line, that I want to design something, I need to have a spectra for my building. So this is your design spectra. At 0.2 second values is there, at 1 second values is there, and all the other multi-period values are already there. Now what to do? Okay, so now what to do? Now you have to go to the database. Okay, so that is what we call it as a NGA2 peer database. So peer NGA2 database, let me see. So this is your peer ground motion database. Okay, NGA, this is called NGA West 2, NGA West 2 peer database. Okay, so we will be taking the NGA West 2 because this will matches with us, or might be for India also. This might be matching, because this is for the shallow crustal earthquake and for active tectonic regions, but the NGA East is basically from the eastern part of the United States, which is the stable continental type of earthquakes are there. So if you like to do it for the say suppose MP or this area, might be this will be the best thing, but for us most of the things from the Himalaya and all these things might be the NGA West 2 model will be. Now if you click this one, NGA OS to this data, then you have to log in. So you can create your own email and you can create your own password. You can give it to them, and then it will automatically, quickly, it will put your permission to use that email and the password. So just only fill up your name and email and your institute. They will be immediately send you the you can create your own password and the login ID. Just you can create that. Okay, so I have my own. So I just click login, and this is your login successful, right? Now, what should I do with this? So I have the design, that this is your design. I need to simulate the earthquake ground motion, right? Which will be matching with the design that I have selected for that particular site. So that means I have to create some time history which are design compatible. So that means design compatible for that site, because that particular site had some seismic hazard. So based on that seismic hazard, there is some hazard level. So that design is compatible to that hazard level. So that design compatible time series I have to generate. So I say that select the models to generate target spectra with no scaling or with scaling, right? So I will be using the providing the AC code spectrum. So I can give this is just only tell you, you can give the user defined system. So that means whatever that your spectra will be generated, you can put these things by clicking this option. Or I am just for make the life simple, I am giving you the AC code spectrum, but AC code spectrum has not been yet updated to that the NGA that the new model. Okay, so but if you when you wish to use the new model, you can use the user defined spectrum, and then you can call those number as it has been given as a CSV. So you can call those number and put it here. So they will take care of that. Okay, so that's the part. But let's do it with a AC code spectrum. So AC code spectrum, they have already. Let me see. Let's see. I give the what is my SDS is 1.16 and SD1 is 0.93. I will be giving this value to them. Oh, sorry. SDS is 1 point. Please. SD1 is. Let me see. SDS is 1.16 and SD1 is 0.93. Right, so this is 0.93, 0.93. Sorry, this is 0.93. So that I have given. I can also give the TL value. They said it is 8, right? So TL value is 8. So you can see the TL value is I have given 8. Okay. So this is SDS, SD1 and TL. So that will be submitting. So that will be submitted. So that spectra looks like this. So this is your AC compatible code spectra based on our two value, but that value are the same. SDS values are the same. So that's your target things. Okay. So this is my target spectra. I need to generate time history based on this target spectrum. So now I search the records. So what are the records I have? I need to search. Okay, now we are from that particular site where you have to design the structure. We need to find out the earthquake on that site. Okay, so close to that site. For that, a seismic deaggregation models is required from that particular area. What are the prominent magnitude that can affect that area, that you need to know. But on an average, I try to say that, okay, I have that area might have a strike slip faulting, all the near about that site, that latitude longitude might have a strike slip fault, might have a magnitude between 5.7 to 7.5. This type of magnitude of earthquake could be there. RJB distance means basically the nearest from the source to the site, that distance. I can say that, okay, this might be 10 kilometer to 100 kilometer distance might be there. And R rupture I need not to give. The VS30 I said that is equals to, let me see what was the VS30, 260. Okay, so that I can give. The VS30 is 260 meter per second. To say I give a little bit more, so I will be give a 220 to 280, so that I have to give a minimum to maximum values. So that I have give. D5, D95, it's a duration of the earthquake that we do not need to give. And you can restrict that maximum number of records you like to see is basically 10 to 30 or these things, but if you do not give, they will be give you all the records available. And so this is the spectral ordinate is the spectral acceleration, so that is fine. This is the 5% damping, that is also fine. The shoot average is arithmetic. You can keep it arithmetic, so that means both the horizontal and the two horizontal records, they are taking the arithmetic average and calculate that values, or you can give the geometric average if you want, because there is arithmetic and geometric. And then there is a scaling method. So you can do no scaling, you can do the scaling also. So I will be saying that minimize this one. So there is a design spectra, and there might be the time history. So I have to multiply the time history by some amount, so that from this multiplied time history, the response spectra calculated, and that response spectra should match with the design spectrum, right? So in that way, design spectrum was being scaled, right? Now, now it is not possible to match entire period, all the periods. So we might need some period to be matched properly if those periods are interested for our seismic design. So we can say that, okay, 0.11, or might be I can give a little bit on the 0.2, 0.3. So these are the things I try to match. So that means if you have a time series, that time series has to be multiplied, and after multiplied the time series or scale the time series, we calculate the response spectra, and that response spectra has to match with the target spectrum, whatever I had given, right? And I had given 111, or might be more, might be because I have added two more, so you can have all the one, so that means equal weightage for all the periods, or you can give some more weightage to some period, some less weightage to some period. That is also okay if you like to give, and then you need to search the record. So it will take time because they will search in the record. So now they will search already, and you have found out how it is matches. So that means all the time history are now match with the provided design spectra you have given. So these all the black lines, the thin black lines are the, see, suppose if I can see it here, it shows that which, it is from Japan, this has matched, the scale factor is 8.4, this is something else, so this is a Chichi Taiwan earthquake. So these are all matched, and all the small time history, its response spectra are calculated, and then this thick black line is basically the average one, right? So all the response spectra are being averaged. So this is the thin black line, and this dashed line are the one standard deviation of the mean values. So these are this one, and it is matches with the target spectrum, right? So that is what we want, right? And here there is all the record that has been used for these calculations, right? So you can see here all the records. You can see that this is your result ID. So this is your spectral ordinate is the SRSS, and then the record sequence. This is your scale factor, how much each record are being scaled. Then this is your intensity. This is the event name, say Parkville earthquake, Imperial Valley earthquake at the several places, and also the magnitude of this one, all the 6.19, 6.53. So these are all the magnitude. And so I had asked them to 5.7 to 7.5, so they had given all the magnitude of the event, then all the strike slip faulting, and also the RJB distance, and the VS30 values for each site, and the lowest usable frequency, and these are all the file name, and these names you will be given a time series, and the time series names are like this. Now, if you do not need to use all the time series, that's fine. You can select some of them based on your choice. So that is your thing. Say suppose I wish to, let's see. So that means, let's see, I use this one, might be, I use this one, might be I can use another one, El Centro earthquake. Okay, so let's see, I have used that. Then I download the data. I can download the data, or might be. Let me see. Where is the download? Why it is not downloading? Yeah. So it will be the downloading the data. So then you can download it, search result. You can see it here. So you will be getting all the information for the full one, and then each one you can get 82 format. 82 is the peer ground database format, and then they had all the information for the period and all these things, and you can also have a time series, acceleration time series, and this is your all the data. You can also get the, I think, the time series data too, if you like to use. So let me see. Yeah, I think this will be the time series data also. Let me see. Yes. So this is the time history for a particular earthquake, and they are horizontal one component, horizontal two component, velocity, displacement, all these things. So we are basically seeing this one. You can download this data. Okay, so that is what I am saying, that where the download time history is here. So this is your download option. So now you can download it. So they will be giving you all the displacement, velocity, and accelerations. And this is your horizontal one component, horizontal two component. So this is your compatible to your design spectrum. Its time after you multiply the scaled one. The scaled one is compatible with this one. So we take this scaled one time history, right? So we will take this horizontal component of the scale time accelerations. Now this scale time acceleration, now we will be taking out, or that time series we take out, and then we will be take that program, whatever we have given you, the strata. Right, so that strata program, I had given it to you. So now in the strata program, as you have seen that, strata, right? So you have, when you will be creating or from the geotechnical borehole data, you will be have all the information about the soil type with depth, right? So these things, say suppose the site where you like to construct the structure, you should have a geotechnical well has been drilled there, and they will be, so this is your geotechnical database. So that geotechnical people will give you the borehole data. Based on the borehole data, maybe it is the sand. Let's see, this might be the Selly sand, and these might be some stiff soil, stiff sand or something like that. And then let's see, this is your engineering bedrock. Let's see, after that, this is the engineering bedrock. So these are the engineering bedrock. Now this is at that point, at the site area. Now you generate the time history which has a compatible, the hazard compatible time history for this area, and you put it onto the engineering bedrock, right? So that you put it onto the engineering bedrock, that horizontal time series, right? And the strata program will calculate, say suppose this is your, assuming that there might be a surface type of things, because everything has to be built on surface. So these data sets will be now propagated through by the strata program. If you give the velocity, density, you have seen that in the strata program. This is the velocity, density, this we have to give, right? Velocity and the density rho 3, this you have to give, and also you have to give the modulus reduction curve and the damping reduction curve. So this is your modulus reduction and the damping reduction. So these are the two curves for each layer you have to give, and I have shown you that this is your Sand and Idris, and there are a lot of options in the strata, so that you have to give this modulus reduction, damping reduction curve for all the things, right? So these 4 parameters, and also the basically the thickness, right? So H1, so this is your H1, H2. So this thickness of this one, and so these are the thickness, velocity, density, modulus reduction curve, and damping reduction curve that you have to give in the strata, and then you give the time series, which is compatible time series for that particular area, and then propagate it through the soil column, right? And then you will be seeing the time series. You will be seeing it for the surface. So this will be the surface time series, surface time series that you can calculate it directly from here, right? So this surface time series you can use, or you can hand it over to the structural engineer. After that, your job is done, because what they will do, it is up to them, okay? But you have provided with the most information from the place where they were trying to build a structure. If they ask your help that you give me some in time series, so that is what you have to do, okay? So if you feel that that area do not have any recorded signal, so there are 2 options you have. One option is this, that you generate a synthetic time series. You generate a synthetic time series by all the information, by using the stochastic simulation. You give the stochastic simulation, that you give the magnitude, and you give the magnitude information and the distance information, and to that program, and you just generate time series, right? So that is one way. If you do not have anything, just give the magnitude and distance and run it, okay? So they will be automatically run, okay? And if you do not have that, then or if you do not wish to generate, sometimes the engineers do not wish to very much rely on the stochastic type of generation. They want the actual record, okay? So that's their main part. They give me the based on the actual record. Now the actual record has not been done or has not been available at that particular site, because that site has not generated any earthquake. So then what should you do? So then you take the record from the other and this peer database, and then make it compatible. But that record, say from the Turkey or from the Taiwan, it is based on their particular site, their hazard level. So that earthquake has been recorded elsewhere. So that record you bring, but then you scaled up with the hazard level of this site, and make it a compatible to this site specific hazard level compatible time series, and that you get it down, and then that scale time series you put it here and pass through this 1D strata program, and that will help you to generate a time series, and that you can give it to the engineers. Anybody has any question? Have I?
Everything I'm to, like you said, what the clean. Like you said, what the with is being one to be bambed down. Like I'm not scared. It's out to like, I think much for the like,
No, basically you are constructing
a say suppose some a big structure in United States, right? At some points, let's see at the Wyoming, right? so some city, and you need the data. Okay, now I know that Wyoming has this much of hazard level, but I don't have a recorded data in Wyoming. So what should I do? But I know that particular site has a possibility of magnitude up to say 5 to 7 magnitude earthquake may happen in that area. That is based on the geology of the area, or basically the earthquake source present on that area. So there are possibility of fault can rupture 5 and 7 magnitude earthquake, but yet there is no earthquake. Okay, so then what we do, we had based on that information, this AC hazard tool have generated a design level of spectrum. So that is that particular site. So we can use that design things as a target spectrum, and then bring the earthquake from the other countries, other area, and multiplied with some numbers and scaled it up with the hazard level of that particular site. So that is a time history which is compatible with the hazard level of that site. And that scale time history we had put as an input and then propagate it through this soil and try to calculate the time series. This soil information is your site specific. So that means at that particular site, this is the soil. So I will be using that part. Does it make sense? Any other question?
That was getting this time history to the result conversion prediction equation. Are you there yet? We are not using a going down motion prediction equation. It's actual dynamic. This is the time history, recorded time history. So we have nothing to do with it. The ground motion prediction equation has already been included when they generate the design spectrum, because they know that this is the fault type at that particular place. So that geo database, whatever I'm talking about, that geo database already included based on the some of the ground motion prediction equation. They have created this spectral hazard level using that data. So that is already included. So you have you need not to do the ground motion prediction equation. Ground motion prediction equation is only required if you wish to generate the earthquake hazard map of a particular place. So this earthquake hazard map is already being generated. So you just extract the information, put in the place. Does it make sense? It's like, yeah. The for synthetic time series, user can use stochastic simulation. Huh? Yeah. So like the information about magnitude and this else for the real earthquakes and meanings. No, it's not a real earthquake. It's just if you feel that it is some sort of a deterministic type. So that means you know that this fault can generate 7.0 magnitude earthquake. So you use that maximum value and then that distance, whatever the distance of the fault from there, and you calculate the time series. Is there any software or which one? On this synthetic time series? I had given to them. They had already. And so they can generate. You just ask them to send the money, and when they send the magnitude, and they will generate. So anybody has any other question? What about the Lucknow group? My start. Are you sure? Is it too hard to do? Because this is mostly done by the geologist. I'm saying that there is nothing the seismologist one. This is all.
So you said this enter party. In that case, can I join the party because I've had generated before?
Oh yeah. So basically send the money. Well, ask them.
Once what to join them?
Okay. So basically, this thing has been generated for all the geologists who do not need to know this thing. Only click the things and get the results. Okay, so that is what basically is, so just only you need to know what you need to do. So, and AC, that website, AC hazardtool.org, you just click any point in the US. In future, it will be coming for India also. But if you can click that, any place, any site, you can generate that hazard map, take the hazard map, put it onto the peer ground motion database, and ask them to compatible all the magnitude of earthquake, generated it, then run this strata website or any website which is the shake or proshake, any website to only propagate through the soil column, because this is the geotechnical borehole that the place has been already generated. So you pass through it by giving these all the information, the depth, velocity, density, and all these things that the geotechnical people will give it to you. So put these numbers, run it and get the results and handed it over to the engineers. That's it. Okay? Is it clear? So should we end it now?
Yes, sir.
So I have.
If you have something to say, then.
No, I have. I hope everybody likes these things, or everybody likes the course. If you have any question or anything, always feel free. And I do not know, I am not included in your WhatsApp group, but if you like to add me, and if then.
So, can you provide your email address?
The email address is my first name and my last name. The DUTTA. U Datta #2 at alaska.edu. Edu, education, edu. Okay, udutta2 at alaska.edu.
We actually go back to our offices and start working. So we need your time, sir. Please, if you get spent, like maybe the once or twice, if we can have online discussion.
That online discussion,
Yes.
I don't know, that much is not possible. But if you can send me an email first, then that will be much more convenient, so that I can say that, okay, this will be this I can answer, or might be, sir, I can write you the. Okay, so if you can add this, so then you can send the text in my group also. Okay, that's louder. If the too much disturb me, I can block it. I have no problem with the students name that. I know. So take anything, anytime, if you need any help, definitely. But don't hesitate to ask me. But otherwise, hope you have enjoyed, and hope you have at least learned something. And that is what. What we have the validity function at Saint Game is like easy boy. Because the Saint Game where we are covered in our vision. Okay, so in the three function, we are expecting that among users share not for some of the force. And last year, West can say something about by coming to the mic. Okay, so we prepare for that, and tomorrow we also have an exam of 2 hours of technical. I said that we'll get one, they have this there, okay? So there's would be objective type questions, there will be short perspective questions, and the total marks will be in the okay, so select the meeting content, you will be provided with the certificates, okay, and your mark sheet will be sent to you by the year. Yeah, okay. Or